right, welcome everyone to the IIoT World Day conference. The topic of this particular panel will be in reference to how AI impacts the future of the workforce. The team that we have here is from all the same organization from ASU, Arizona State University, and they are all the incredible team that's accomplished an NSF Convergence Grant on developing a technology to help the workforce and more particularly the individual contributor level advance with what appears to be exponential growth in AI and technology that derives from AI, artificial intelligence. So we'll go over a couple of different things. We'll go over the format of this conversation and also how to perform the Q&A function. We won't be using the chat tool. We'll instead be using the QA, which you can find at the very bottom of your screen in your Zoom conference. If you select that, you can submit questions at any time throughout this, and it won't be disruptive to the team. Once we finish both a combination of presentations and video where the team's describing all the work they've done, we'll come back and answer a few of the questions and answers. If we don't have enough Q&A, which I think we will based on how interesting this topic is, we have a few prepared questions as well that we'll go through. And the goal is really to both educate on what the great work this team's doing, as well as to spark some thought around what the future looks like in this field. So I'll go ahead and give a or allow each team member to give a brief overview of themselves. So we'll start with Kurt, if you'd like to take it from here and give an introduction to yourself. And then if you'd like to give an introduction or hand off to each of the other team members, and then go ahead and run your panels.
Thank you, Cody. My name's Kurt Van Lane. I'm a professor at Arizona State University, and my research interests lie in applications of AI to education and training. Erin?
Hi, everyone. I'm Erin Chu. I'm an assistant professor of human systems engineering, also at Arizona State University. I run the Automation Design Advancing People and Technology Lab, which stands for ADAPT Lab. And my research is really focused on understanding how to implement automation in the workplace. Katina.
My name is Katina Michael. I'm coming live to you from Sydney, Australia. I'm a professor at the School for the Future of Innovation in Society at Arizona State University, and also a joint hire in the School of Computing, Informatics and Decision Systems Engineering. I run and direct a group on policy, society and engineering, and I'm very much interested about socioeconomics and socio-technical legal work in the space of AI and robotics. We also have a member of our team who's absent today, who's currently defending his proposal with the NSF on his virtual booth, who was the brainchild of this whole project, Sid Srivastava. Over to you, Cody.
Wonderful. Yeah, and for a bit of background on myself as well, my name is Cody James. I'm the founder and CEO at OpenX. We are working on next generation systems to help advance the field of education and training, particularly related to AI too. So no stranger to this, and we recently won a DoD program to reinvent Air Force and Space Force training systems to keep us updated to the latest technology. So we're very familiar with this field, and it just feels great to talk with other people who, just some incredible minds here. So what we'll do is we're going to go ahead and hand it off to Kurt, and he's going to spearhead on behalf of Sid, like Katina said. We're going to go over just the incredible work they're doing in relation to their NSF grant and any other comments that they'd like to have to spark kind of the thought process. So on this topic. So Kurt, if you'd like, go ahead.
Actually, maybe we should have Sid give his little presentation first, since that's more of an introduction to the whole project. I think Katina has it queued out, right?
Katina,
yes,
if you'd like to share.
I also agree, yes. We'll see the prototype in action during this presentation. I'll just take a moment to set up the slide and ensure it's in play mode before I share my screen.
Wonderful. And while Katina does that, if anybody that's listening in has any questions before they hear anything from this conversation, anything related to what we're thinking about with the future of how rapidly evolving technologies are going to shape our workforce and what our needs are, go ahead and send them the
Alice used to take every training opportunity that her employer provided. Still, She was often frustrated by long waits for engineers to come and debug her robot and explain why it was doing what it did. There are plenty of free online curricula available today, so we asked Alice why she wasn't considering them to upskill herself. It turns out that to go to the next level in her career, she would need an engineer certification, which would take about 5 years of coursework. And as an hourly worker and a single mom, Alice could not afford the time for after-work coursework. Alice's story represents millions of factory workers who are stuck in their roles, not because they don't have the ability to progress, but because they are constrained by socioeconomic factors. To address these problems, we want to develop an AI-based on-the-job training system that will create a new job category, robot taskers. Here's how Alice might experience this new system. On the first day, Alice watches a 15-minute video showing her how to write a sequence of high-level intuitive commands for the robot in a simple language, a language that's actually adapted from ones used by children. She then assembles a series of training devices, making mistakes and getting instruction from the robot itself. For example, she might ask the robot to hand her a washer that's lying on the floor. And the robot may say, "Sorry, I can't do that." Our system will allow Alice to ask the robot why it can't do that. And the robot may say, "It's too flat. If you want, you can attach a magnetic gripper and that will allow me to pick it up." She does that, and the robot safely picks up the washer using our team's research on safe task and motion planning for robots. As this continues, Alice's expertise increases. She gains a reputation for being able to quickly devise clever robot programs that produce devices faster. Her stature in the company and among her co-workers rises, and the workforce culture improves as a whole. This new robot tasker role will be a ramp-up role between that of a robot operator, which requires minimal skills, and a robot engineer. The video on the right shows how a robot tasker assembles a gearbox with 2 robots by giving them only high-level intuitive commands using our system. This was our phase 1 prototype, and it shows how robots and humans can complement each other's skills to develop products more efficiently. For instance, the user in this video does activities that require greater dexterity, final inspections, and so on. Our deliverable is a prototyped robot tasker training system, along with evidence of success and excitement about the robot tasker role in the future of work research and stakeholder community. We've already assembled a strong team of partners, including Raytheon, who will help co-develop and co-evaluate our research in their manufacturing labs. We are also partnering with Arizona Department of Education's Career and Technical Education Division to help ensure that our research meets the requirements of real workers. Toyota has expressed interest in supporting us on other applications of this technology, including healthcare. Modern Industries and Trinity will help us gain better insights on the needs of small to medium manufacturers. UMass will help us assess workers so that our on-the-job training programs start at the right level for each worker. We are particularly excited about bringing Native American community to the table as a part of this project. We are partnering with the American Indian Science and Engineering Society, as well as with ASU's American Indian Policy Institute. These organizations will help us learn how to develop our solutions to help upskill members of this community. On a broader scale, this technology will help US manufacturing, a sector with almost 13 million jobs, to become globally competitive and more responsive to changing product designs and consumer demands. It will provide a skill ramp that allows workers to learn on the job and to upskill themselves. We also plan to apply the insights gained in this project to develop solutions for other domains where non-AI experts are expected to work with AI systems, such as healthcare robotics and logistics. Thank you for watching. We look forward to your support in this endeavor. We welcome questions in the virtual booth or over email.
Over to you, Cody.
Wonderful. So that's a great introduction video on kind of the work that really is emphasized within that NSF grant. And when we go around the table, each individual is going to talk about a different specialization within that functionality. As you can imagine, a complex system like that doesn't just appear, and it's definitely not driven by just one person. So each team member here is going to provide a level of expertise on a focus within that larger complex system. And we'll go ahead and start with Kurt and then work our way around the table. Kurt, once you finish your introduction and comments on your work with this NSF grant, feel welcome to hand it off to the next person, and we'll go from there.
Thank you. I appreciate the chance to talk a little bit about workplace upskilling. However, I would like to talk about a completely different workplace than the one that we're targeting in the NSF grant that you just heard about. The NSF grant is focused on manufacturing, and manufacturing has already enjoyed a fair amount of automation. McKinsey reports that of the job classifications that are out there, the least likely to be automated, the one that would be most difficult to automate, is teaching, particularly K-12 teaching. So we've been looking at what kinds of job aids could help automate that, and also include some on-the-job training for the teachers. So we have a project also funded by NSF that's doing that. So I thought I'd present a little bit of that if it's okay with everybody. Let me share my screen. I'll give you a few slides on that. Here we go. There. Now, can you see my screen? It should say.
Yes, we can.
Okay. Well, it's an automated teaching assistant, so it's a job aid for teachers. Let's make sure that we can advance. So this is one of our collaborating schools before we introduced any technology. They spend a lot of time in these middle school math classes solving problems in small groups while the teacher circulates. And occasionally the teacher will grab a piece of student work and show it to the whole class, or at least try to. You can see that you'd have to have very good vision to be able to see all the things on that poster. A lot of the stuff on these posters the kids are generating is complicated. So the problem, according to us, was that the teachers who kind of have only a few seconds when they walk up to a group can't really analyze the work thoroughly enough. So our concept was, oh, and here's another one. This is another poster where the students have not only written some math, but drawn a graph and so forth. So it's complicated. How can the teacher make sense of this when they only have a few seconds before they can start talking to the group? So our initial design concept for an automated TA was that it would monitor all the students' work and do that analysis, but it would only present the analysis to the teacher in the form of a set of updated issues. And that allows but because it can do it to all the students simultaneously, do that analysis all the time, we gave the teachers a dashboard. They can tap on the icon of a student group and see that student's poster along with our auto TA's analysis of it. That allows them to have what they need to know when they walk over and start talking to the students about that issue. Alternatively, if it's a particularly simple issue or a particularly high functioning group, they could just send a message already prefabricated by our system. So we thought this would be a great job aid for teachers who are trying to circulate around a bunch of students who are doing complicated work in small groups, which is typical of a lot of math classes. This is the system as it's being deployed, as it was deployed in a California classroom. The teacher carries a tablet around which has the dashboard, and the students are also using tablets in small groups. They have a shared workspace which they navigate around. They have cards that they can drag around and they can write with a stylus and so forth. I'm happy to show you the details of these user interfaces, but it's not really that important for this talk. What did we discover? Well, first thing we did was compare our system to paper. So here's essentially the same classroom in a private school in Britain using either our system at the top or paper at the bottom. What we found out is that our system cuts the wasted time in half, which is good. However, it didn't have much of an impact on collaboration, which according to the ICAP theory of collaboration is should have happened, but didn't. unfortunately, we discovered that one of our key measures, which is whether students' struggle is productive, we didn't do so well. In fact, the paper students did better. So our second design concept, after analyzing all the log files and videos that we collected, was that most of the groups needed help most of the time, but the teacher couldn't visit very many groups in the classroom. So a lot of groups were left waiting for the teacher to come visit to get advice. So we said, well, FACT can just send them that advice. It has it. It's just been waiting for the teacher to act on it. So let's just have FACT do that under certain conditions. So our second study evaluated this. And again, fortunately, this worked. It increased the amount of productive struggle that was productive, and that was good. But still, collaboration was rare. We wanted to see more of it, and we weren't seeing it. So moreover, we got a lot of reports from our observers in our analyses of the videos that the pairs often didn't understand the messages sent by FACT, which is understandable given that it's just a message. It's not an ability for the machine to converse with the students and clarify what its first utterance was. So as a consequence, after a while, the students began to treat the messages from FACT as spam and just ignore them. So not good. So we went to the teachers. We said, what's the problem? We had these structured interviews with our main teachers, and we adapted a bunch of questions from a classic work on teacher-centered design. And what we discovered in these interviews was, prior to what our second design was, the auto TAs should not try to do tutoring. The teachers actually want to do that. That's the part of the job that they feel is most central to them. That's part of their professional identity. What the auto TAs should take care of is all the minor stuff, helping students understand the task instructions, because oftentimes they'll just sit there staring blankly if they don't understand what to do. They need to remind the students to stay on task. Sometimes they just sort of drift off accidentally. They remind students to explain to each other, not just one student does all the work while the other watches. You need to have some explanations and some back and forth. A key thing is that since students are of differing abilities, when the fast workers finish early, the teacher normally gives them extra work, but if the teacher doesn't come over, they just sit there. So FACT now gives them extra work, should give them extra work. Now, sometimes it happens that the class, as I just mentioned, there's a lot of them sitting there waiting for tutoring. So what do? Well, we give them what help we can, and if that doesn't work, then we call the teacher over. We give them a few lightweight hints. That's kind of all the teacher wanted. That's what we should be doing, but we weren't doing it. So we're in the process of building that system. But when we tried some piloting, we discovered that oftentimes the teachers who told us exactly what they wanted taught in a way that wouldn't work with that. And in fact, it was more of a didactic, traditional lecture type way of working. They said they didn't want to do that, but they were doing it anyhow. So what should we do in that case? Should our technology help them do what they want, help them do what they're already doing, or help them do something that we know from research is the most effective? That's almost an ethical question. What's the most ethical way for an auto TA to work with a teacher? If the auto TA does take some autonomy on itself and teach either according to what the teacher should do and not what they are doing, or teach according to the best known principles, well, if it takes on autonomy, will the teachers kick it out of the classroom? There's an old saying in America about too many cooks in the kitchen. Well, in this case, one cook owns the kitchen and will cook the other cook out. So that's where we're at right now. We want to put the system out in the classroom and see what happens. Thank you for your attention. That is definitely a workplace, real different than the manufacturing. Thank you.
It's fantastic and extremely interesting. I think everyone here, irrespective of background, can see some relation to the value of that, whether employers thinking about their teams and employees on how they can grow within their role, or anybody here from an academic background can understand the value of that from students. And if anybody has any questions, please load up the Q&A so we can go through them at the end. I mean, this is a great opportunity to talk with people who are doing this every day and are spending their life on it. So it's extremely interesting, and thank you, Kurt. Appreciate it. And Aaron, if you would like to go ahead and give a bit of background and anything else from your side.
All right, are you all seeing the correct screen?
Yeah, we can see your screen.
Okay, great. So today I'm going to talk a little bit about the human systems engineering perspective when it comes to this project that was first introduced in Sid's video. And so this is going to be a little bit high level, but hopefully by the end of it, you'll see sort of how we are prioritizing our contribution here. And so first, I want to at least clarify what human systems engineering is. I often get this question, so if you don't know what it is, it's okay. That's very common. What our field does is really we try and understand people and then how to design technology and systems that can best empower or fit human systems. So it's basically a combination of psychology and engineering, but our focus really is on understanding humans. So implementing AI in work systems, a human systems engineering perspective. When putting this small talk together, I had to think, well, why do we want to implement AI in the work system? Oftentimes it's to achieve operational excellence or to obtain competitive advantage in an open market. And so this is really what I see as a very common promise of AI in the workplace, is to either automate or innovate. And Deloitte recently came out with a 2020 report that talks about just this, and they survey a bunch of companies, and this is really what AI is trying to do. But before we even get into talking about the technology, there have been 3 common approaches to achieving operational excellence and obtaining competitive advantage. And that is to proceduralize the work. So that might be providing processes and procedures that then standardize the way that you work, and you can introduce a lot of efficiency that way. Another way to do it is if you are operating in a very uncontrolled environment or difficult to predict environment, is to shift control to the front lines of where that uncertainty is. And so oftentimes that means, if you're working in a factory setting, that might be shifting it to the frontline workers, which is really what this project is about, is introducing not just this ability to upskill, but also for the companies themselves to adapt quickly if you need to develop new materials very quickly and have a huge turnaround in terms of design. You can shift some of that uncertainty to the front lines. And so that's another approach. And the third one, which is not exclusive of the other 2, but is often to add technology. So, you have salespeople out there pitching their awesome technology that claims to do a lot of things, and that it should be an easy swap in, right? Where they can, fulfill a function that's been really well scoped. And so that is also a common approach. So there are some problems with these approaches. So when you proceduralize things, these often only address the knowns. So they help reduce ambiguity. It's one way to coordinate. But on the human side of things, this often leads to rule following, which again, given your task environment, that might be something that you want. You want people to follow rules and procedures. But when you're talking about really complex systems, unpredictable environments, rule following is actually very bad, because you want people to adapt when the rules can't cover what it is that you need to do. And you need people to be able to make good judgments. Similarly, when you shift control to the front end, although this enables discretion when unknowns occur, so something unknown happens, and then you empower the front lines to use their discretion and make their best judgment. But when you are talking about really high risk situations, potentially with safety implications, this then requires expertise. And so this is really the gap that we're trying to address, which is, if you have to invest a lot in your workers, which we still need to be doing, but oftentimes this can be very costly for companies, and that's why we have an education system, right? Is to hopefully, or even technical training, where you can offload some of that cost through education and upskilling. But otherwise, if the company has to do it, it's very expensive to do, to basically enact training that will then create experts. And so that third component, technology, similar to proceduralizing, but except you have the benefit of a machine doing it. It can increase efficiency, consistency, can help reduce human workload, but it also introduces system gaps. So this is also talked about in the Deloitte report, not to plug that too much, but I just happened to have read it earlier today. And really, when you are introducing new technology into an existing work system, it's not as simple as just replacing a function, because often you need people who have to maintain the system, who need to learn how to work with the system. And I think Katina might get to some of this in her talk, so I won't step on her toes too much further. So these gaps that new technology brings into the work system, I think is what here we are trying to understand what those gaps are and then how to fill them. And so I think if we want technology to be a solution, it cannot be evaluated on its internal structure alone, but on its role as a coordination mechanism. So again, this is talking about work environments where you can't pre-program everything and just run it like traditional automation, where you're just following a bunch of rules. Unfortunately, the way that we've been evaluating a lot of this technology has not changed. So we're still evaluating it based on, oh, is it doing what we tell it to do? If so, then it's performing great. But ultimately, when you're working in these really unpredictable environments, I think what will help increase the resilience of the overall work system, which includes more than just the technology, is understanding how much the technology is able to facilitate coordination between that network of that organization. And so just to quickly conclude and wrap it up, what we're proposing as part of our project is considering more process-based performance. So rather than outcomes like, did you hit this certain return on investment metric, is more about understanding the process that the technology introduces into that specific task and the work system as a whole. And also understanding whether or not, or to what extent, the technology is able to allow the system to resolve conflicting goals. So again, when you have complex systems, by definition, it's not something that you can pre-program or pre-plan. And so you will have conflicting goals that arise potentially at the local level that you need to address at that global level. And so what I think is really the promise of AI in complex systems is, does your organization have the superior doctrine and understanding of the whole work system? Because technology is easy to acquire, it's easy to copy, but are we using that technology well? I think that's where the competitive advantage will come. So in conclusion, I think that we really need to be building capabilities that allow for whole system adaptation. Of course, technology plays a very important role in that, but I think we can't lose sight of how that impacts the rest of the system, which is, I think, wholeheartedly human. So that concludes my presentation, and I will stop sharing and allow Katina to go next.
Well, thank you so much, Erin, for that overview. I feel very close to your area of research. As we've said so often, it's almost like this present mode of operation going towards a future mode of operation, but it's not that easy. Change management is very difficult. Actually understanding the user's requirements is also difficult. Often roboticists and technologists and engineers seize on these opportunities because there is a business case to be had. And in my background in the telecommunications industry, training was a big part of our bids as we went to provide a tender forward and a response to people who needed things. And often training was the first thing to go. You know, what's this 20% figure or this 10% figure or this token $20,000, depending on the relative cost of the system itself. The higher the top of the capital expenditure, usually the greater the percent of training costs. So we were always wrestling with, well, this is our Rolls-Royce response to the actual operator or service provider, and in this case, organizations. But when people start to look at the bottom line, they do actually go for those training costs and try to slash them out of oblivion. We don't need training. We have a whole bunch of very smart people. The robots will do the work and the AI will be smart enough. But still, even though we're introducing adaptive training systems, we need training for the adaptation of the training systems we're introducing. So in the business case, we can say, we're going to do nothing, we're going to do something, or we're going to go with everything. And those various levels of detail are determined after a business case is done. And really, with robotics and AI in this particular system, we are looking at several factors in the business case. One is, can we increase our revenues? Two, could we minimize our costs? And three, could be a story about compliance and regulation. And so in the future of work that I look at all of these various things that are elements in the business case and try to tie them back to user design principles. And that's where my work intersects with Erin Chu's work on human systems engineering. Erin goes down to that task level to look at now what do we need and how will we do it? And at the same time, I'm looking at the socioeconomics. And I'm also looking at the socio-technical legal as I will present today. I have a few affiliations, of which I'll name a few, with the IEEE, working in their RFID Council as a board member, with the Society on the Social Implications of Technology, because this is going to change everything rapidly. We're not just talking about automation, we're talking about the step after automation, which is really what we're calling the fourth industrial revolution, or AI-fying our manufacturing or retail processes. We've already seen COVID give us a jolt with regards to where we're going. And it's not unusual now to walk into retail outlets that actually have no humans whatsoever. Here in Australia, there is a chain that you all probably know very well, Target, owned by Myers and a few others. And they have literally got one person on the floor that I've seen when I visited recently. The rest is kiosk-based and the rest is self-service. And this has been very interesting to watch, how consumers are also becoming a part of the future of work. It's consumer work. We go to buy something and we do everything that the worker previously did. So I think there is a rapid change here in the digital transformation that is occurring. We as consumers are also part of the worker sort of expectation. We now take our own goods, scan them through the checkout. We now take them and test them ourselves before purchase. I also work for the Australian Privacy Foundation. Some of you might think, what in the world would the Privacy Foundation have to do with the future of work? But I want you to think about a future where you turn up and you've got robot co-workers who are waiting for your every command, almost at your feet, saying, what do you want me to do next? I'm ready to go, let's do it. And so through these interactions, which are being captured on audit systems and being logged, there is some form of surveillance going on as well. So it's going to be a whole new contractual agreement when workers decide to take on an employment opportunity at a workplace. I see this when we're talking about robots for aged care facilities that are there to take linen throughout the facility so that the nursing staff or carers of the aged can be set free to do other tasks. And we also see this with robot vacuum cleaners in large establishments like shopping malls. There they go around and the imagination says, well, there's no need to clean anything anymore because people are looking for the robots to do the cleaning. And we can see these different kinds of use case scenarios where we think, now what is the requirement? Interestingly, when I've given interviews online about the implications of robot vacuum cleaners, the implications of robots at aged care facilities, the establishments haven't wanted to slash the labor cost. They've been more interested in upskilling and reskilling. And this is where our work really comes in handy. In order to get to this point, we interviewed 23 people from various industries, some of them from the high-tech fabrication space, some of them from chip manufacturing, some of them from aged care and hospitals, nurses. And it was very interesting to hear their anecdotal stories about what they do day in, day out, and how adaptive training systems may well be the answer to some of their woes. And so as I go through fairly quickly in this presentation, I'll make sure to reference some of these things. So what we're seeing is industrial robotics everywhere, autonomous systems coming in. They're ubiquitous in manufacturing. My father, who was a glass factory worker, a leading hand back in the 70s, basically his job was taken in the early 80s through automation. He used to be the one looking at broken bottles on the conveyor belt. I'm glad he doesn't have glass in his fingers anymore, but such was the displacement where he was actually made redundant. What we're looking at now, because if all of these workers are made redundant, is new opportunities for them to actually interact. It's not about robots replacing humans. It's about co-workers. It's about working together, finding out which tasks the robot can do better than the human perhaps, or is less dangerous for the human to take on, or is more dangerous for the robot to take on. And so we start to look at danger, harm, all of these ethical scenarios, justice issues even in this process, what should be taken on by the robot and what should be left alone to be taken on by the human. But there is this collaboration that we're talking about, and we're hoping to see in all sorts of things, even detailed kinds of scenarios where the task is to put together a very finite piece of equipment, maybe, for example, on aeroplanes. So there are many dimensions I've gone through fairly quickly: the economics, the technical, the social, the legal, and these relational issues between each. I don't want you to think that economics is the winner here, or the technical is the most important, although roboticists and engineers will often tell you, we just want to talk technical. But increasingly they're becoming aware that user-centered design is so important, which is why Erin's work and Kurt's is so significant. The legalities around this. Well, what happens if there's an accident in the workplace and it is the fault of the robot, but the human, it has been harmed? How do we deal with these governance and policy rules within the organization? And all of these things are jostling for space, mind space, corporation space, executive space, and also societal space as we navigate through them. Everything here is new. And previous analyses, literally when I look at socioeconomic templates and I look at papers that have been written on this space, they're all very surface level, very high level, the revenue, the operational expenditure, the capital expenditure, and yes, the net present value is. But there hasn't been significant work done on the actual sub-line items, which shed light on the actual practices. So at first glance, replacing humans in the workflow seems incredibly cost-effective. Robots don't take breaks. They don't have health and life insurance requirements. There's no injury compensation. You're not going to get by the robot employee a bill at the end of the day for a sore back. And there's no family leave and so much more. Well, that's the misnomer, that we think at first point that this makes total sense. But as Elon Musk learnt, he said he went completely digital too early in the manufacture process of some of his products and stepped back from that, announcing that on Twitter about 6 months ago. So there is a consideration here to be had. There are costs for introducing a digital transformation process and products in your manufacturing plant. These include, it costs energy to run systems, digital systems. There's maintenance, and maintenance doesn't happen like once a year, like taking your car for a service. When we're talking about robots, they break down quite often. In fact, anecdotal evidence tells us from organizations we've spoken to in general that in fact, it costs people a lot of money to stop the machine, go and see what's wrong with its production, why is it happening, correct something perhaps in software or in the hardware componentry, and then start the process again. And in fact, we call this a buckle in the supply chain often when we are, for example, with large sheets of metal trying to manufacture things and we've got a stoppage. And that rolling stop actually costs organizations a lot of money throughout the year. But we are looking at product, quality, volume, and other kinds of indicators that we know in the manufacturing space. There are costs from errors and faults. We spoke to some informants who said, look, it was producing things, it looked right, but it didn't fit. And the workaround was not actually to change the instructions, for instance, in the 3D printing. It was to keep going and somehow make the most of that mold by adding another sediment or component to actually get it to glue together, which again is not good practice because that leads to faults further down in product development and design. Training and adaptation to new environments. You can't really expect your workers to turn up and go, okay, you know, now we've got a system that we can look at and ask questions to. People need training, and from many people that we ask, what kinds of training would they like? They actually mention video training. They've often relied on their co-workers for on-the-job training, but sometimes co-workers make mistakes in how they actually tell the instructions. So a video, or for example, some system that we're wearing that we can look down towards and get on-the-job instructions, and next, as we do that. We've investigated that over time. Also obsolescence. The speed at which we are creating products is so quick that, in fact, buying something for the long term may not be necessarily what an organization wants to do. Maybe they want robots as a service and they're paying an ongoing fee. So rather than it being a capital expenditure where you buy a bunch of robots for your manufacturing plant, what you're doing is looking at this over time in an operational capacity. So it's, you know, like photocopiers. If they break down, we'll take it away and we want another one that works. So perhaps what we're doing is going through a system of economics where we're thinking about these things. And we've got to look at it longitudinally and contextually. We just can't say this rules or these rules fit for all of the manufacturing companies out there. Context is really important. Bringing the worker back in the loop. you know, getting away from this mentality that says robots are going to do everything. You know, I look at these reports, I'm very cynical about these reports that have written off 30% or 40% of the workforce. What we're trying to do in this project, and I hope we get the phase 2 $5 million raise grant that we're bidding for actually today. What I think we want to do is make sure that we're going to maximize the amount of people who can stay in the workforce, even if automation is coming through at rapid fire. What we want to do is maintain people's work environments. So if they get displaced by a machine, they're able somehow to be in the loop of another machine that helps the company generate more revenue. How do laborers feel about introducing robots into the workflow? A lot of them have safety questions. A lot of them have comfort questions. You know, I forget command lines very easily. Do I have to remember a set of commands, as Kurt was alluding to? Or is it more intuitive? Can I use natural language? Is it going to be like talking to an Alexa? And the other thing is, robots are not just physical. Many of them are going to be chatbots. They're going to be software-based without actually a hardware enclosure. And most of them will not be anthropomorphic, even though we see this in science fiction all the time. More practical may be arms that actually lift things and put things in places. Feasibility, is it feasible for a number of different feasibility issues, and worker and system expectations. So human-robot interactions, if you take anything away from this talk, they're socio-technical, they're bi-directional flows. They're not just unidirectional. It's about robots responding to humans and humans responding to robots. And can we acknowledge the efficiencies of robotics without displacing the workers, as I was saying? How can we get more workers to be upskilled quickly by using these kinds of systems? They become even more useful to their corporations, allowing them to entertain ways of seeking more outcomes. And strategies for protecting laborers. We haven't really talked much about legislation, but redistributing job tasks, retraining, reskilling. And I gave the example of the vicinity shopping centers that had introduced vacuum cleaners. But as I know from anecdotal evidence, there are some things that those vacuum cleaners can't pick up, like small staples that have been accidentally dropped somewhere, particular types of materials, like liquid materials. So early project directions, characterizing multiple working environments. Do we want an environment that's human only? And where do we sit on that human to robot spectrum? Well, we sit somewhere where we need both humans and robots working together. Building the business case for training and worker engagement. I'm an advocate of reintroducing the training component better than we've ever done before, because that is actually something that will help us produce better items. It's not just a training component that you tack on, it's embedded into the user design process. Optimizing task distribution, the notion of lifting and moving, tasks that are computational, that are sorting, adaptive tasks. Which ones can the robots really do faster and more efficiently? And where do they collapse in terms of complexity in problem solving for that task? What about last mile tasks? Are they good for robots or not? What about precision tasks? Does it help us to have a robot building those precision tasks where they can, you know, millimeter error can mean that a product fails? And mixing. Anticipating extreme and exceptional scenarios. Well, scenario planning is there to be taken. I know with a lot of our autonomous systems, enough scenario planning has not taken place. I would advocate to asking employees to actually build their own scenarios and embed them in the process and participation so that they are co-designing alongside the technologists. HR practices, do the policies actually clash with what is going on the factory floor? Regulatory systems, are they in their nascent stages to respond to something, or are we going to end up with million-dollar lawsuits, multi-system workflows, and internal policies? Will we ever have no human in systems? And the answer is no. Machines have physical lifetimes. So do people. But we are able to bring in people to this process. Humans are responsible for design to a degree, maintenance, retraining, upgrading, and replacing. I just can't leave the factory there like that outlet I was talking to you about where you just do self-service at the kiosk. It doesn't work like that in highly complex systems. Human training is essential for building a workforce that can identify, intervene, interrupt exceptions, especially when things are going wrong, And that socio-technical legal system is important. Who's at fault in an accident? How does human error place responsibility unfairly on workers? Oh, it was the worker's fault, when in fact, the machine has been caught red-handed. Can rigorous training protect workers both physically and legally? So robotics in the workflow is a multidimensional issue that requires a multidimensional solution. And I want to thank you for the opportunity of going through that presentation in some level of detail. But if you have any questions, I'm happy to answer them after this presentation. Thank you. Over to you, Cody.
Okay, there we go. That was a lot of ground covered, so thank you, Katina. We appreciate it. And while I'm going to go ahead and give the last couple of minutes here, I'd really encourage anyone to ask questions on what they just heard there. I want to recap the things that we've gone over, just emphasizing, first and foremost, for anyone that's attending this, we really want to emphasize the role of AI in its transition to the workforce. And we live today in a really unique time where, unlike the past, when we've had major surges in technology, whether it's the Industrial Revolution or within that, the adoption of machinery, which would expedite production and expedite these laborious functions, similar to what we're describing today, the real unique thing that we have at this time is a new level of collaboration, even being able to share these thoughts between experts and have people hear it and ask questions and incorporate it into their work. This is very, very unique. So please, ask any questions you can and really try to think about the things that have been going over today, from restructuring in our minds, how does artificial intelligence, or how does a machine learning kind of expedited program really fit into our organizations? How does the infrastructure underneath that brings the new workforce in, how does that need to be recreated to support that? And then after we've considered both how to get people into this new workforce and what this new workforce looks like, let's consider the implications of it. I think all the panelists would agree with a simple phrase, which I heard back when I was a robotics programmer, which is that a hammer to a human is a robot to AI. And that's a really important distinction. A hammer to a human, a tool to a living entity or a system, is very similar to a robot to AI. So artificial intelligence can be leveraged in a wide array of different functionalities, whether expediting documentation in a legal sense, or it's on a production floor actually expediting production of physical components. We would really benefit as a whole understanding these distinctions and then breaking down, like Kurt described, how is the infrastructure in which we bring people into new technologies, like Aaron described, how does that perform with what we have today? How is the human and machine relationship? And Katina emphasizing that same point and even bringing in, what are some of the implications that we're not considering, and what are things that we should really think about as we go through this journey of next generation of technology? I think that there are three different types of question kind of groups from the audience. I think one of them is, I'm working on advancing my career and I'm trying to understand how can I jump onto this wave of adoption. I think the second one is out of curiosity. It's tell me more about the algorithms and so on, and let me understand more about how this works. And the third one is, I'm an employer and I want to know, how can I accept more of this into my organization? And I'd encourage a couple of different things. One, there is a AI manufacturing event for IIoT, which is in September. I think that would be a great next step. But in addition, I'd really pay attention to the work that this team is doing at ASU and really focus on reading into their research or their white papers, and then the contributions they're making with the National Science Foundation to understand a couple of these different dynamics. And I'm sure none of the panelists would mind if you reached out to them and asked more about their work and how that can contribute towards your organization. Also, I'd recommend reading Kurt's book on mind bugs. I think that a really important note in adoption of new technology is that at any point of anything we say, really just as like humans, we're always giving kind of our best guess. We are a accumulation of all of our assumptions over our life and all of our experiences, and that comes with a lot of flaws in the structures and a lot of assumptions and a lot of preconceived notions, where just because we can rationalize something doesn't always mean it's true in terms of when we want to bring in new technology or enact new policies or new processes. And I'd really emphasize the work that he's doing in terms of understanding how mind bugs work, or Kurt, I hope I'm representing this well, but understanding different structure shortcomings even within us. So I think that those are a couple of really important notes just as kind of a wrap up to this. And Katina, I think that was great what you were saying about the relation, the socio-technical relation. I feel that as well. Okay, just reading that comment. So back in my career, as a quick note, when I worked in robotics programming at Boeing, I was in advanced production systems. And actually, when we came in and were automating a lot of structures of airframes which were being riveting, you could almost understand how important all of the things we've gone over today are in the real world production environment. Things from what are the assumptions that we have in the introduction of automation systems into real life production? What are the implications of how does this work socially? What we found was one of the biggest benefits was health. You know, working as an airframe mechanic, you're riveting all day, and this really wears down the cartilage between, your anatomy. The robotic system, beyond anything else, that was one of the best results of it. So really understanding that this is a multi kind of factor discipline, that there are a lot of implications and there's a lot of things to be considered. I'll go ahead and jump in and answer a few of the questions, but really awesome work and it's a great panel. So this one is what change management elements are key success factors? And I just want to emphasize, we just have a few minutes. So if I could just call on a couple of panelists, and I'd love to answer some of these before we wrap up this, this conference. This one is what change management elements are key success factors? Presumably, if I'm running an organization, I'm a manager, what are things that I should be considerate about, whether my employees are adopting new generation technology or I'm putting new generation technology into our process flows? And Aaron, I think you had some great comments on that if you'd like to answer.
Yeah, if I were to give a one word, so change management, it's like a whole course that you could take, or probably even a whole degree. If I could answer it in one line, it would be talk to the people who are doing the work. Because if you're high up and you're making decisions on technology acquisition, it might seem easy that you can simply replace the function, but they are probably filling in functions that technology has not considered. And if you don't talk to people doing the work, you're going to end up with a mess.
Wonderful. I hope that everyone can hear this well. And I'm going to go through here. I think that this is a really interesting question. I really encourage anybody who wants to raise their hand to answer this one. But how do we feel collectively with your guys' background and experience that a higher productivity of artificial intelligence and robotics, so presumably for production, would change our understanding of human value in society? And that one's, it's a socio question, so it's very philosophical. So feel welcome to chip in. How do you feel, if I could zone in a little bit further, how do you feel the value of a human's contribution in the economy would shift with a lot of labor being automated? Katina, if you'd like to answer that one.
Sure. I think I'm an advocate of humans first. I always talk about human factors, human values. These are things that just a small % of the society will work out. We have to really engage workers. We have to engage citizens. We talk about participatory design, user-centered design. Just like you were saying, you don't want people stressed out on their cartridges. Maybe what you need is a robot arm that just basically helps us, like we see in automation and in the car manufacturing companies, auto companies, that it lets you bolt on the door, but you're not doing the heavy lifting. How many nurses out there would love not to be having to lift dead weights, even if they have a hoist that's semi-digital? You know, these are the things that we're looking at. Where can robots serve a wonderful space, a gap? You know, we don't want people to be like my father was, mixing food additives at the age of 60, inhaling these additives at 200 kilogram drums because it was displaced from another factory. So I'm really looking at how will this enhance human life? We want life-enhancing technologies, life-sustaining tech. And if some of this work that's dangerous, not good for us in our health conditions or otherwise, can be, inverted commas, given over to the machines to help us with our goals, I think that's the primary aim here. humans come first. The machines are helping us to achieve an aim. And it's basically taking stress off our bodies and perhaps even our minds in the future.
I think that's a great way to put it. And just as a final note, if we could emphasize that, I would really emphasize that this shouldn't be intimidating or like a kind of scary new technology to introduce. If you think about humans, like we have two kind of modes, it's capacity and capability. And today our capacity is so overwhelmed and doing these laborious functions, which we really don't need to be doing. A lot of things like packaging items and shipping items and so on, that if we could expedite those, we could really focus on humans being able to tap into our capabilities as a species and advance further like we always have, and hopefully continue well to do. So I think that's a great way to put it. Appreciate it, Katina. And is there anything else we'd like to go over before we wrap up? We're just 1 minute past the mark now. Would anybody like to give any closing comments? All right. Well, how can everyone that's listening to this keep up with your guys' work? Go ahead, shamelessly, plug anything that you guys are working on. I know that we have some links, and then I believe the session is recorded, so people can find your contacts on the ends of your presentations. But how can someone keep up with your guys' work?
Email, website, Twitter. It should be all in my presentation.
Yeah, just, let's
Go ahead, Kurt.
Couldn't hear that one too well, but I think I got the message.
Kurt?
Well, wonderful.
Something, Kurt? Sorry.
I just said email is a good way to,
Oh,
I have a website at ASU as well that has many publications and other links on it.
Yes, definitely. The Fulton School of Engineering at Arizona State University has a lot of work there. The Public Interest Technology Program, which has its own website now, Public Interest Technology, where we're looking at technology for the public interest, and we are alluding to emerging technologies like robotics. Our personal website, katinamichael.com, and of course the work of Tit Srivastava, Nancy Cook, George Fanekos, and so many of our partners. They're on the website, so have a look and get in touch.
Wonderful. Well, thank you all for your time, and thank you for everyone that's attending for listening in. This is it's been great. So thank you guys all, and thank you Aaron, Kurt, Katina, and Greg and IIoT for hosting this event. And yeah, I'm excited to see the work that you guys do and how it evolves.